So, hello everyone. My name is Guillaume. I'm located in Lausanne, Switzerland. It's 2 p.m. my time. I've just had lunch, and I'm the engineering manager for the search platform team at Wikimedia Foundation. Name of the team is confusing because yes, we do search, but we also do Wikidata query service. Yeah, I'm here to talk about scaling Wikidata query service. David, do you want to say a few words about who you are?
Sure. I'm David. I'm a software engineer for the search platform team, and since a few years, I'm maintaining the backend for Wikidata query service. We are trying to scale it. So this is what we're going to talk about today, Guillaume.
Okay. Given this is the Wikidata Modeling Days, I assume most people know what Wikidata query service is. Still, just to make sure we're on the same page, Wikidata is, in my terminology, Wikidata is the component that runs on MediaWiki with a Wikibase extension. That's the place where we edit Wikidata, the project. It's backed by MySQL, which is the usual backing store for MediaWiki, but is a terrible backing store if you want to do graph queries. So what our team does is we take all those edits, all that data, we push it to a graph database, RDF store. In our case, it's BlazeGraph. That allows us to expose a Sparkle endpoint that anyone can query. Yeah, in term of terminology, when I talk about Wikidata, I mean usually the MediaWiki component, like the primary storage of the data. We can use that same Wikidata to talk about Wikidata as a whole, as a project, like the Wikidata project that englobes all of that. In this presentation, when I'm saying Wikidata, I usually mean the MediaWiki part of this, as opposed to Wikidata query service, which is a query part of this. Wikidata query service is core to how edits happen on Wikidata. A lot of the edits are automated. There are a mix of writing things to Wikidata and checking what needs to be written on Wikidata query service, but it also provides like visualizations. For example, there are a number of researchers using Wikidata query service for exploring whatever subject they're interested in. That's one of the one of the entry point for data reuse. That's bringing us to the scaling challenges. Graph databases are hard, scaling them is complicated. At the moment, we have three facets of scaling that we are dealing with. First one is the write load. Wikidata sees about 1 million edits per day. All of those edits needs to be ingested into Wikidata query service. This used to be a problem. We could not keep up, and we were throttling down edits just to make sure we could keep up with Wikidata query service. We've done some major work in how we have our update pipeline ingesting the data. We've gained roughly a factor of 8 in terms of throughput. So that problem is, at least for the moment, under control and mostly solved. We have a challenge in terms of read load, like the number of queries we're getting, the complexity of those queries. It's a problem that, to some extent, we can address by throwing more hardware at the problem. And we're also dealing with it with throttling, rate limiting, not allowing a single user to overload the service. It's not ideal, but it's not threatening the survival of the service at the moment. Our last problem in terms of scaling is the data size. Wikidata at the moment is at around 1 billion triples. We're growing at a rate of around 1 billion triple more per year. As far as I know, Wikidata query service is not the largest public Sparkle endpoint on the internet, but one of the largest one. And we're already seeing some issues with our current system. The backend that we're using, BlazeGraph, has scaling issues. We do see random data corruptions that happens on our production systems. Hopefully not, luckily not too often at the moment. And those are related to the data size. So we have strong evidence that with more data, we're going to see more of those problems. The reloading all the data at this point takes around a month, sometimes more. Also, because when we're reloading the data, we're adding more stress on the system. Like we're ingesting data faster than we do during normal operations, and we're reaching those problems faster. We're also seeing that some queries are taking longer. Things that used to be working in a reasonable amount of time are now timing out. We've done some investigation to see what other RDF backend we could be using instead of BlazeGraph. And what we've seen so far is that of the few stable open source alternatives that exist, scaling beyond the current size of Wikidata is not a given. So even if we change the backend, that might not be sufficient to continue growing. And to some extent, if we can get that size under control, that gives us more option to evaluate as alternative backends. As a general comment, like we've been talking with a lot of graph experts over the last few years, and it seems that everyone agrees that scaling graphs is hard. It's not a solved problem that we have a simple solution for. Just check. Yeah. If we don't do anything, what's going to happen? In the worst case scenario, we get to a point where we can't ingest more data. We get frozen in time for WDQS. Wikidata continues to move forward, but we're not able to ingest those new edits. We do have a playbook for that. Like if that happens, we know what we're going to do, and it's going to be ugly. So we prefer not doing it. We might also not be able to recover from a catastrophic failure. Like at this point, if we have a catastrophic failure, it's going to take us more than a month to recover. That's not good. We're not there yet. Like things are not completely broken yet. We do have SLOs, and we're reaching those SLOs reasonably well. So we're not in a catastrophic moment yet, but we want to act before we're there. So what can we do? Sorry, I'm getting lost in my slides. Yeah. So obviously, if size is a problem, we can reduce the size of Wikidata. And there are some good ideas on that side. Like we can reduce duplication. There are things around multilingual labels, automated descriptions. Like we know we have a number of entities in our graph where the description is just a copy of the parent description. That's not adding any value. We could have a system that automates that and doesn't store it. But from our analysis, that's going to gain to reduce the size by millions of triples, and we need to reduce the size by billions of triples. So that's good, but that's not going to solve our problem. There are a bunch of things we could do that we really don't want to do, like stop editing, randomly delete data. We don't want to get there. One of the options that seems to be reasonable is thinking about how can we split this graph and use federation to federate the various components of that graph. Like federation is core to linked open data. It's already happening. The Wikidata Query Service has an allow list of around 100 Sparkle endpoints that we federate with. And anyone who has a Sparkle endpoint can federate with Wikidata Query Service. That would provide a way to scale horizontally. Like we can have disconnected graphs that can each scale independently. That's splitting the problem in smaller manageable problems. We don't want to split the data randomly. We want to have a split that's easy to understand and to navigate. Like if we decide to split like every entity that has a description in English that starts with an A goes to one graph, and everyone that has starts with a B to a different graph, like that's going to be a mess. We're not going to be able to reason about it. It's going to be crazy to try to navigate that graph. Not going to work. The goal of that split is to reduce the size of the graphs we manage. So we want to make sure that the largest component of that split is at most 75% of the current graph size. Ideally, we want to split it in half. We want to minimize the number of queries that needs to be rewritten due to federation. Like if a query needs to access both part of that graph, it will need federation. That's not going to be transparent. So we don't want to put too much burden in rewriting queries. Federation is also going to raise the cost of some queries, the queries that needs to be federated. So we want to minimize the number of queries that are going to not work because they become too expensive. And also we want to make sure that for most queries, query time is not increasing, hopefully decreasing. So what kind of split can we do? There are a few ideas. We could split like the truthy graph versus the full reified graph. That doesn't really help because we still need the fully reified graph in some cases. So we would have a smaller graph, but our biggest component is still the size of the current graph, not helping. We could split in a horizontal way, like have the labels or the description or the aliases in a separate graph. That's not very good because in that case, most queries are likely to require federation. It's going to be fairly disruptive. Which leaves us with our last option, which is a topical split. We do have large subcomponents in that graph, astronomical object, scholarly articles. The one that seems promising at the moment is scholarly article. It represents around 50% of the graph at the moment, so that's perfect in terms of size split. It represents around 2.5% of the queries, so we're minimizing the number of queries we're going to affect with this. And it's reasonably easy to understand. We know, like, if we do a split based on scholarly article, we know that anything that is a scholarly article is like an instance of Q. I'll let you read it. Is in one graph. Everything else is in a different graph. I'm going to talk a little bit more about this. In this context, we've used the names the scholarly article graph for that graph we would be extracting, and the main graph, the main Wikidata graph, for everything that stays in the same place. So what is the plan? Is there a question? I'm hearing some echo, I think. Okay, no one. So we want to experiment at this point. We don't know if that solution is a good solution. To be confident that we're moving in the right direction, we want to start with exposing 3 endpoints, one with the full graph, one with the scholarly article, one with the main graph. That should allow us to compare things. Like we can run queries just on the main graph, just on the full graph, make sure we have the same results. We can run a subset of the queries that we get from our logs, see which one are affected, which one are not. We can get numbers and we can have a better understanding of the impact. We also want to get feedback from all of you. Once we have those endpoints, we want as much as possible, people playing with it, people telling us what's not working. We want to learn. The way we want to define the success of that experiment, and success means like we're happy with it, we're going to go forward and try to push that into a production system and change the way we think about that graph. We want to reduce the size enough that the stability of the system isn't threatened by the size of the graph. The measure of that we're using is we're able to reload the data in less than 10 days on the current system. That should allow for a size of up to 20 billion triples. That should allow for 5 years of growth, which is reasonable. In 5 years, we'll need to revisit what we need to do. We want the query time to not increase for most queries. We don't have a good definition of most at the moment. We want a number of queries requiring rewrite due to federation to be minimal. Again, like we don't have a good definition of minimal. We need to work on that. And we want the number of queries failing to be minimal. Again, no good definition of minimal here. We're not changing Wikidata. Like we're not proposing to split Wikidata itself and extract a new Wikidata for a different topic. We're only working on the WDQS part of this system. We're not going to do other experiment besides scholarly article. That's the thing we're focused on at the moment. If our experiment fails, if we see it's not the right solution, then yes, we might explore something else. We don't know yet what it is or what it would be. We're not going to go forward before we know it's a good and viable solution. And even when we take the decision, it's going to take time before we get there. Experimenting with a split is or putting in place a graph split for experimenting is reasonably easy. Making sure we can take a flow of updates from Wikidata and split it into various update streams for those various subgraphs is a significant additional amount of work that we'll need to be doing. So we have an optimistic timeline. By the end of January next year, we want to have a stable testing environment. At the same time, we want to start testing queries on this. We want to get feedback. We need to get some system in place to gather that feedback. That's not yet there either. We'll communicate about it when we're ready. And hopefully by the end of March, we want to have some kind of decision of, yes, this is good enough, we can move forward, or no, it's not. Let's try to find something else. And yeah, that's what I had. We're here and open for questions, discussions, suggestions. And as Lydia said, if anyone can help with the notes, that would be super helpful.
Thank you so much, Guillaume. There were a bunch of comments and discussions and questions. I'm going to try to fit them all to you. One discussion that's ongoing is around an update stream. So being able to regularly update another system like Clever based on an edit stream that we provide. And yeah. Is there a public one? Is there not a public one? There's discussion around that. Maybe you can clarify.
So there is, yeah, I see someone who replied that special recent changes is a public update stream and can be used. It's not ideal. In a perfect world, like we would be publishing an RDF stream of changes. We do have that internally. It's not entirely trivial to expose it publicly, in part because it's constrains us to have a stable interface for this, and it's yeah, it's not standardized, it's not well documented, and yeah, so that's something we've been discussing multiple times. It's clear that there is value to this. In terms of priorities, like, we want to focus on that experiment on the graph split before we take on anything else. Like, we don't want to be distracted at this point. But that's something that, yeah, we recognize it's useful and it should be done eventually.
Guillaume, can you be a bit more specific? So there is a public update stream, you're saying? What's the format?
David, I'll let you go into more details. You're probably better than me on this.
Yeah, so the Wikidata query service can be updated with three different techniques. One is using completely public APIs. So basically, the recent change is a feed of all pages that have been updated, and then from there you can fetch the RDF content from that page. So it will be on your own to like pull the update stream and fetch the RDF content and then update your backing storage. But it's possible. You have to write some tooling for that, but it's possible, because I know some people are keeping their Wikidata query service updated on their own without any public RDF stream. What we hope to provide is something really dedicated and focused to RDF, which will be super easy to consume without the need to go back to MediaWiki. So the stream will be almost self-contained. But we haven't had time to work on that yet. But it's something we really know that it's going to be useful for people, because we can provide it for Wikidata, but also for Commons. So I think that's something really useful. We hope to work on soon.
Cool. Then we have another question from earlier. How about using a labeled property graph system and GQL, I assume GraphQL, for the query service? Labeled property graphs appear to match Wikibase better than RDF does.
So I feel like Sparkle is really something important for people. So if you're going to change the language, that would be a first big burden, I guess, for people to change from Sparkle to something else. And in our testing, I think some people tried to load Wikidata into some property graph, and like this was kind of bit of difficult to do, so we didn't explore that a lot.
Cool. Then
I think there is Peter who has a raised hand and would like to reply to this.
Yeah, can you hear me?
Okay. Yes. Yes.
Okay. So yeah, I was the one that asked about labeled property graphs, and given that I'm actually in the RDF community more than labeled property graphs, I suppose I could be considered heretic for asking this question. But one of the big problems with the Sparkle queries on Wikidata is that you have to stand on your head and blink 5 times fast to get the queries correct. Particularly if you're doing something beyond the truthy stuff. It's really hard. So it appears to me that a GQL query on the non-truthy stuff would be so much easier than an RDF query on the RDF feed. That's the reason that I would want to do it.
We got very clear signal before that Sparkle was essential to Wikidata as a project. And it seems to me, with my understanding of how the project is working at the moment, it seems that adding a different way to query the graph as an additional way to query it might be reasonable. Completely replacing Sparkle by whatever other query concept is unlikely to go well, and it's going to require an insane amount of effort to migrate all the tooling and the things we have around it. I might be wrong.
Yeah, indeed. And in your defense, of course, labeled property graphs and GQL are the new kid on the block. I mean, when Wikidata started, they were not nearly in they were in a much worse shape than they are now. Not that they're saying that not that I'm saying they're in a good shape now, but but they've improved a lot in the last 3 years even.
Hannah.
Thank you. I think it's just not true. I mean, they're essentially equivalent, these other query languages or labeled property graphs, and there's just a certain complexity to the data. And if you ask, the queries are as complex, they are just different. Maybe for one particular query, you can write it a little bit nicer in the one language than in the other, but it's just not true that all the queries are complex in this language and simple in the other. It's just there is no free lunch. There's just a certain complexity to certain queries, and I think it's more important that you have good help for constructing the query. But so, yeah, you are not escaping this. GQL, the queries are as complex on the average. It's just slightly different. So I also don't see the point of switching.
All right, we have a bunch more questions, so let's get to the next one, maybe, or do we dive deeper into this? Peter, maybe one last thing, and then we move to the next one.
Just to push back on Hannah, querying non-truthy information in Sparkle is horrible. I mean, dreadful, horrible, ridiculous. Nobody can do it. It's, and you know, whereas, and that's not because of Sparkle, it's because of the things you have to do to go from the RDF, the Wikidata multigraph model to the RDF non-multigraph model. And so that's a huge class of queries that are much easier in a good labeled property graph system. Not that I'm saying that there are any.
It's just not true. It's the same with wherever you put the data, it will be hard. But let's discuss it offline, maybe.
Cool. Next question for you then. James Held is saying, experience with the Commons Query Service suggests that Federation can handle joins with a query of internal sets within the query of up to 20,000 rows, whereas pure Wikidata Query Service queries can contain joins of internal sets of up to 1 million rows or slightly more. Do you have a good set of sample queries to understand how many Wikisite queries would involve substantial joins across the split?
Oh, sorry, Guillaume.
Go on.
No, that's exactly the purpose of the test. Really testing how far we can get with Federation and how the current modeling of the data is friendly to such Federation system. So we know, yeah, in advance that maybe some use cases won't be possible using Federation, but how can we? Are there workarounds? Can we solve that? Can we have different ways to solve these use cases? Because one also problem that is brought by SparkQL is that it's so powerful that you can do anything, but maybe it's not the right tool for the job. So we might also ask ourselves, is some broken use cases can be done differently with other systems? But yeah, that's the exact purpose of the test, knowing the limits of Federation. And I hope with this test, we can also learn a bit more about how Wikidata can be shaped in a more federated ways, but that's a different topic.
To add something on this, like the splits, we want to experiment with a scholarly article, and we know the big use case in that space is Scholia, and so we want to interact we have started talking with people from the Scholia project to better understand how it's going to break for them and how we can help. We don't know yet, but we want to find out, and that's going to be one of the key is this experiment a success or not? And just to be clear, like, we are going to break things, and there's no good solution that doesn't have a drawback. So it is going to make things more difficult or impossible in some cases. but we don't see a way out. Like, we can't grow indefinitely in the same way without doing anything.
Cool. And then the specific question James had around, do we have a good set of sample queries? We're getting it. Cool. Then Tom is asking, I wonder to what extent we could totally rewrite to federate queries post-split. Would it be possible to make this totally transparent to the user?
So not for the first iteration. We will sadly rely on people writing explicit federation Sparkle queries. I have no clue how we can help users in shaping these queries in the future. We might add some syntactic sugar, as we call them, to help them, like the label service. But it's also something we have to really think about carefully, because everything we add that is not standard Sparkle can also be a burden for the next the base draft replacement we will experiment with. So yeah, so I don't have clear answers to that yet. Sorry, Guillaume.
Yeah, our starting point here is that we want to reduce the number of queries that will need to be rewritten. It's never going to be completely transparent, even if we do have an automated system. Like, there are performance implications, there are implications on the size of the joint you can do. It's going to fail in different ways. We might be able to put in place something to help, but there is enough complexity that this is adding a lot to that project. And also starting to think in terms of subgraphs might be a long-term good investment.
Cool. Then we have a comment from Andy. There's more than one QID for P31 and Sandorov academic papers, academic journal article, for example.
So the question, the question is around how we define what item go where. So we first try with a very simple criteria, which is instance of scholarly article. We know that it's not perfect, but this is where the bulk of the data is. Like just this simple criteria is really half the split. And we also had discussion about if we go something a bit more complex, it might be difficult for people to know what endpoint to use for what use case. So that's why we start with this. It's not set in stone, but yeah, we don't want to have crazy rules that are really hard to understand. So that's why we started with that. And we agree that it's not exactly the truth.
Cool. Then we have a question from Olia. What about splitting asteroids too?
It's a much smaller subgraph than scholarly articles, so it doesn't fit our definition of having the largest component at most 75% of the current size of the graph. So, like, that's the answer of why not splitting out astronomical object instead of scholarly articles. Why don't we split both scholarly article and astronomical objects? Because we want to limit the amount of disruption. If splitting out scholarly article is sufficient, then there's no reason to split more. One of the things we don't want to do, like, we're technicians here. We're the people like running the machines. We know how to run servers. We know how to run a service. How to actually model data, like, that's your job, guys. That's why you're joining this conference. At least that's my assumption. It might make sense or might not make sense to start thinking about Wikidata as a whole, like is this something that makes sense as a single project or as a single graph, as a single place? Or do we want to start thinking about sub-projects or sub-graphs in some way? Like, that's a conversation that's super interesting, but that's a conversation for people doing the data modeling, doing the thinking about what do we put in Wikidata. We're just the bus drivers.
All right, then we have another question. Will WMF consider in some time of the future to fix the Blaze graph limits, whatever the final approach would be?
No. No, clearly, our job is not to be database writer of graph database software. That's not our mission. Blaze graph is unmaintained; it's not moving forward. What we will most probably do is look at alternatives that already exist and maybe work with the people who are already supporting those other solutions. Like Hannah is here, and I'm sure she has something to say about it. But there are not a ton, but there are a few open source RDF stores that exist that might fit our need, and it seems a better solution to move to those rather than to try to resurrect a project that seems to be dead, and share our efforts in moving something forward rather than resurrecting something.
Cool. Then we have from Sky. The splitting strategy should consider what's happening on Wikibase Cloud. With the development of more domain-specific graphs, where we may end up with some aspects of the overall global commons being directly invested in on a regular basis. We need to blend that kind of focused development of entities and claims with the more wide open churn of everyone trying to make sense of the world. Another way to think about the split is between the more stable and less mutable aspects of the content stores. The basic aspects of bibliographic metadata will be pretty stable once correct. An important thing to work through, though, is how do we model the additional claims that will arise over time about the subject matter in an article. Does that go in an additional claims derived from the content in the Wikidata item as it is described, or does it go elsewhere in the graph, like via provenance, linked via provenance?
I think that's a great suggestion. That goes in the right direction. But again, I'm just a bus driver. That's a question that's larger than WMF or WMD or actually Lydia might have the best answer to this. It's more in her domain than it is in mine or David's. We're talking about how do we model data.
Yeah. So yes, I agree. Things like Wikibase Cloud and the rest of the Wikibase ecosystem is definitely something we need to keep in mind. And this whole federation topic is not just going to be a topic for this split, right? Like much more data will be in other endpoints, Sparkle endpoints, and we will want to query them together, and that's going to happen via federation. So it's going to be a thing one way or the other. Cool. Then more questions. James asks, how much extra time and load will be put on the query system updater if it has to chase up a P31, P279 chain for each item every time there's an edit to determine which query service to update?
So, yeah, this question is about how we make that into action, how we implement the splitting rules into a production system. That's a good question. And for now, if we stick to the very simple rule we have, it will be simple because the decision will be local to the entity. But if we do something more complex, then yes, that will be a lot more. We will have to write something a bit different, but we are not there yet. So that might be something we will have to solve later. But we can discuss that if everyone wants. But I'm not sure it's we need to.
And just to get a little bit into the nice implementation details, the update pipeline that we have is independent from the backing store. It's based on Apache Flink, if everyone wants to know more. And that's a system we know how to scale. We can parallelize that workflow. So it's scaling independently of the RDF backing store, which was one of the reasons why we created that new update pipeline. It's because this is something we know how to scale. It doesn't mean everything is possible. I mean, there is runtime complexity, but there's also that conceptual complexity. If the system becomes too complex that we don't understand it, then it's not going to be stable. But we have a lot more leeway there than we have with something that's close to our scaling constraints.
Cool. Then we have another question from Adi. Where will the actual split occur? Will it take place on the Wikibase instance of wikidata.org on top of MediaWiki, or within the internal components of WDQS?
We don't want to touch Wikibase, Wikidata, like what I refer to as Wikidata, like the MediaWiki, Wikibase component. The primary storage should not change. We've had some conversation about hypothetical, depending on like the complexity of the graph split we want. That might be something we could go back on, but that's something we want to avoid as much as possible. And when I'm saying thinking about it, that might be something like we've talked about that split at some point, saying like if the split is really complicated in terms of rules, maybe it's better to let our editors or a subset of our editors to decide which entity goes where, and we would be adding some way on Wikidata itself to flag an entity to be in graph A or graph B or both or something like that. But that's a very complex machinery. Like it was more a random idea we had than something we really want to try to experiment. So as much as possible, no.
Cool. Then Jane and Nicola are asking, are Wikisource articles included in the definition of scholarly articles? Most Wikisource pages are not articles, but we do have a lot of scholarly articles on Wikisource.
I'm not sure I understand the question. Is it like knowing if like a Wikibase scholarly article site links is going to refer to its wiki source or something like that? I'm not super aware of wiki source, so if someone knows, please answer.
Nicola,
Yes,
do you want to answer?
So I'm working a lot on Wikisource and doing queries on Wikisource. And basically, I want that after the split, if there's a split, I can still do my request, my query as usual. And we do have books, novels, regular thing on Wikisource, but we also do have a lot of scholarly articles. So I'm wondering if I want to do query related to site links or other things, it will still be possible and ideally seamlessly. That's it.
Yeah, so it's hard to know in advance. So I think that's really the purpose of the test. So once we have the test in place, I hope we will have like a kind of projects page where everyone can go and share their feedback and use case and ask questions about whether or not this is going to be possible. So I think answering your question, Nicolas, without knowing the query is hard. So I think, yes, we will have time to discuss the feasibility of your queries.
Cool. Then Marco is asking, how does Wikibase scale at the moment compared to the BlazeGraph Sparkle endpoint? I presume the MySQL database is federated and load balanced.
Not my area of expertise. It is not shard. I mean, it's sharded in terms of reads, but Wikibase, like the Wikidata database, is mostly a single database. So there is no horizontal scaling of that component. I'm always surprised that it works and it still scales, especially given like how we're implementing structured data on top of MySQL. But we have amazing DBAs, and they would be better suited to answer this. As far as I know, like we don't have we're not scared about scaling Wikidata at the moment on that side. That being said, Wikidata is one of our largest Wikipedias, and or like our largest wikis, and there are a number of cases where it's not blocking, but it requires special attention. Like we're doing search as well, and search on Wikidata is a difficult proposal as well, in part due to the size of that data set and also the multilingual nature of that data set in terms of search. So yeah, Wikidata is a special case in our ecosystem.
And as Tom says, don't jinx it. All right. And then Arthur is asking, what is the timeline for this experiment?
I think I had a slide about this. Where am I? We want to have something public at the end of January where we can experiment on it, start getting feedback, and start ourselves running test queries, having a test plan that we can validate that experiment. And hopefully by the end of March, we have enough data that we can at least move forward with having a good feeling that is that a reasonable experiment, or is it a complete failure and we need to find something else. There is vagueness there. Like we're going to learn along the way. Like we know the kind of questions we want to ask, but we're going to learn more by doing tests and understanding the limits of the system. And yeah, there is fuzziness. We don't exactly know. And like once we have a decision, like actually doing the work to put that in production, that's a much longer timeline, and we don't know yet.
Excellent. We have 2 minutes left in the session, and we are done with the questions that I can see. But I have a question for you. What can people do to help you make this least painful?
At the moment, start thinking about it. Start thinking about your use cases, whether you might be impacted or not. And we'll get back to you when we do have that public endpoint, and start testing. Start telling us how it breaks, how it works. And yeah, we want to hear about those use cases, especially the ones that don't work, so we can try to address them. Tell us. Yeah, that's the point where we're really going to need your feedback. If you have feedback before that, like you're already convinced this is an absolutely terrible idea, we should stop right now, let us know. Like we probably disagree, but we would like to have that conversation. If you think it's awesome, we want to hear about it as well. On the slide, I think I have a contact information for our team. We have public office hours once a month. If you want to continue that discussion, that's a good place to meet with the whole team and ask questions, have discussions, object.
Thank you so much. That was super helpful and insightful, and I hope that we can make this all work.